After finishing the editing, click Code at the top right to generate the 86HMI editor code. EtherCAT's QEC is an industrial Arduino-based EtherCAT solution with a dual-core Vortex86EX2 processor developed by DMP Electronic to achieve hardware and software real-time requirements. The QEC family is a friendly hardware and software EtherCAT device that will satisfy all kinds of users who expect to use EtherCAT. The QEC system contains two components, the master devices and sub-devices. This is a master device equipped with a 9-inch touchscreen display. The display size options range from 5.7 inches to 15 inches. The QEC M series is an EtherCAT main device that uses a dual-core, independently operating DM&P Vortex86EX2 processor for real-time, reliable synchronous EtherCAT control. Next, we will introduce the different sub-devices. The first type is the analog input and output sub-devices. The next one is a digital output sub-device. The next one is a digital input sub-device. The last one is the human-machine interface gateway module. Integrates rich EtherCAT gateway functions, including RS-232-485, MPG jog, keypad, and LCM. Here is a demonstration of my small project. In this setup, I connected a potentiometer to a sub-device that supports analog input and output operations. When I turn the knob clockwise, please note that the 9-inch display updates and gauge reflects the corresponding setting. The gauge needle moves to the corresponding value. When I turn the knob counterclockwise back to 0, it marks the completion of one full cycle. I continue repeating the completed cycles, each time setting a different peak level. The next page displays a log of all completed cycles, including the cycle number, the completion date and time, and the peak current value with the corresponding percentage. After completing several cycles, we press the Next Page button to move to the next page and view the results. Press the Reset button to clear the records and return to page 1. Confirm by pressing Yes. The entire process can be repeated multiple times. When the Reset button is pressed, the records are cleared and the system returns to page 1 to begin a new cycle. Now we will discuss the software development. Download 86Duino IDE 501 from the QEC website and open the IDE 501 application. Double-click the downloaded folder and find the 86Duino application program. Double-click the 86Duino application to run IDE 501. With 86Duino IDE 501 running, click Tools and choose the correct device and COM port. In this project, I'm using QEC M090T connected to my laptop through COM4. Now we can scan the hardware setup for all master and sub devices. Click the 86EVA configurator button in the top right corner. To start the scan, click the Connect button. After scanning, the QEC M090T and all sub devices will be displayed. Click Code Generation to allow the IDE to automatically generate code that includes all the detailed information about the hardware setup. Click on OK to complete the coding. After scanning the hardware, the IDE generates 3 files: header file, C++ source file and JavaScript source file. Now, we can start designing the HMI display. Click the 86HMI editor button at the top right. From the list, select the QEC M090T device we are using and then click OK to continue. Add an image gauge by selecting it from the list and dragging it onto page 1, as shown in the example. You can adjust the colors, sizes, and effects using the Properties panel on the right. Spend some time exploring the settings and select the ones you prefer. Adding an image bar to page 1. Adding a button for the next page. To add page 2, click the Add Pages button as shown. On page 2, select Label and drag it onto the page as shown. Under the Properties panel on the right, change the text to Record. Add a table page 2 by dragging the table object from the left panel onto the page. Then set the desired number of rows and columns in the Properties panel on the right. Add 2 additional buttons to page 2. Adjust the text, style, and color settings in the Properties panel on the right as desired. After completing the design, select Save As. From the top left corner to save the HPI file. Once the HPI file is saved, select Code at the top right to generate the header file and C++ source file. IDE 501 will automatically create 2 new files, header file and C++ source file. Save the project on your laptop or desktop computer. You may later upload the project to ChatGPT to request assistance with code development or improvements. Open ChatGPT and upload the project folder generated by 86 IDE 501 so it can review the files and understand your hardware setup. When creating your prompt, use plain English and clearly describe the objective you want to accomplish with your hardware setup. The following is my prompt that I wrote to ChatGPT for my project. I am developing a small demonstration project for our QEC system. The hardware setup includes an analog subdevice connected to a potentiometer used to indicate the current analog level. I created 2 HMI pages using the HMI editor. Page 1 should display both an image meter and image bar that update according to the potentiometer value. A complete cycle is defined as turning the potentiometer from 0 to any target level, and returning it back to 0. Page 2 should record the timestamp and level for each completed cycle. I will upload the project files. Please review the project structure and modify the code as needed to implement these functions correctly. Once your prompt is ready, click the Send button to submit it to ChatGPT. Allow ChatGPT a few minutes to review the uploaded project folder and analyze your prompt so it can understand the objectives of your project. After ChatGPT completes the analysis, it will generate a zip folder that you can download. Extract the zip folder, open the extracted, and locate the INO file. Then open the file. Press Ctrl+A to select all the code in the file, then press Ctrl+C to copy the selected content. Return to the IDE and paste the copied code into the sketch by pressing Ctrl+V. Click the Verify button in the top left corner to compile the code and check for any errors. After the compilation completes successfully with no errors, click Upload to send the project to the QEC M090T main device via a USB Type-C cable. After the upload process is finished, return to the main device. Turn the potentiometer and verify that each function operates correctly. If the result isn't what you expect, go back to ChatGPT and ask it to fix the issue. ChatGPT will provide an updated file for download. Repeat the process until your goal is achieved. I would like to add more features to my project, such as a print button on page 2 that saves the records as an Excel file to a USB drive connected to the QEC M090T. ChatGPT will provide a new INO file. Download it, open the file, and copy and paste all the contents into your sketch file to replace the old file. Repeat the previous steps, verify the code, and upload it to the QEC M090T if the compilation finishes without errors. Before uploading the project to the QEC M090T, insert a USB drive into a USB port and confirm that is formatted as FAT32. After uploading the project to the QEC M090T, turn the potentiometer knob and run a few cycles. Press the Next Page button to go to page 2. On page 2, press the Print button to save the records as a CSV file to the USB drive. After removing the USB drive from the QEC M090T, connect it to your computer. Open the saved file in Excel and verify that all the recorded data is correct.